Hey guys, Mr. Bowman here. Today's learning objective is in yellow and we are learning to measure and estimate angles. So the first things I'd like to underline are the idea of measuring an angle and estimating an angle. So when you've been asked to measure an angle, you're normally looking to be exact. And if you're looking to do that, you've always got to use a protractor. And being online, this use of the protractor is going to be fairly difficult, but hopefully our worksheet works out for us. But you can see an example of those protractors down below. So we'll get into that example first, and we'll then look at the other two examples where we're going to be estimating. So hopefully with our protractor, you can see both ends start at 0. So there's a 0, and then it goes up to 10, up to 20, up to 30, and so on, all the way up to 180 at the end. And if you go in the other direction, you can see a smaller 0 underneath, and then it's going up these 10s as well. And this time around the middle, it's going all the way up to 180. So there how we use or how we measure. So each big lot, so we can see that there is 5, and then the bigger line makes 10. The small one makes 5, the bigger line makes 10. So we can use all of that to count pretty accurately the angles that we're looking into. So we'll look at the red one first, and because we're starting on the right-hand side, we are starting at 0, and we're looking at the smaller numbers along the middle. And you can see that pretty quickly hits 50 degrees, which means we here, or that red one there, would be 50 degrees. Now you're looking at the blue one. The blue one's a bit harder because it's not attached to one of the ends. So what you need to do is you need to figure out each of these. So we're going to go across up there. That looks like it's hitting 40 exactly. And we're going across this way. That looks like it's getting 105 exactly. And to find the answer, or the bit in between, you need to go 105 degrees minus that 40 degrees, which would give us 65-degree angle there. That was a protractor example. Now let's focus on this idea of estimating. When you're estimating, you can't be exact, because that's what the definition of estimate means. It means you're giving it a guess. And what I suggest we do is when we've been asked to estimate, we're using something that I call the quadrant approach. And this here just narrows it down and helps you come up with a really good estimate. So let's just come up with an example, and we'll use our space up the top here. So that's our dot, or this here is one of our lines. And going this way, if our line comes out anywhere in this direction, we know it's going to be between 0 and 90 degrees. So somewhat here, 0 and 90 degrees. If we carry on, we're adding in another quarter. So hopefully you can see quarter 1, quarter 2. If it's anything in this range, we know it's going to be somewhere between 90 degrees and 180 degrees. And again, we're going to add in our third quarter over here. Anything in this direction, that's going to be 180 degrees to 270 degrees. And finally, 270 degrees to 360 degrees. And that there, bottom one is our third quadrant, and the top one is a fourth quadrant. Once you've identified it, so let's say our line's coming out in this direction here. We know it's somewhere between here. We're now just going to focus in on the quadrant of interest. So as a fraction, how much does that go through? And what I'm thinking here is if I drew another line this way here, that looks to be thirds. So there's a third, there's a third, and there's a third. So 1/3 of this 90 degrees is going to be 30 degrees. So it looks like that's going to be another 30 degrees, and that there would be another 30 degrees. So if we add the 90 from above, the 30 here, and the 30 here, that should give us our 150-degree estimate of that line there. So that's what I mean when I'm talking about the quadrant approach. So I'll change pen colors to wrap up our video. We've now got two quick quadrant approaches that we've got. So first thing I will do is I would extend the line. So that there makes it 180 degrees. And I would draw a line going upwards, which makes it 90 degrees. So what we can do is we can see it's somewhere between 0 degrees and 90 degrees. So we're now looking at, well, what portion of the 90 degrees is this gap here? So what I'm probably going to be doing is I'm going to be tempted just to keep drawing, just kind of like that, chopping it up, just to see what portion we have. We can kind of see maybe it's into quarters. So you've got quarter one there, so that's 3 out of 4. So what we need to do is we need to find, well, what's a quarter of 90? And so 1/4, or written 1/2, but 1/4 would be roughly 22.5 degrees. And if you had 3/4, that there would be 77.5 degrees. And that there would be my estimate. It's less than that 90, which we figured out from the top. And I broke that gap up into quarters, and I've got myself a rough estimate. And our final question, the big one at the end. So again, we carry on with our 180-degree line, and we draw our perpendicular line, and we can see, well, this here is up to 90 degrees, and that there is up to 180 degrees. So it's somewhere between 90 and 180. We're then going to think, well, what proportion is that? So if you have a look, we can break that up, probably breaking it up into quarters again. So we know that's going to be another 22.5, that there will be a 22.5, and that there will be a 22.5. We add them all together, that's going to be 167.5 degrees. So guys, hopefully you found this video on measuring angles and estimating angles using the quadrant method useful. Now that you've done that, hopefully you've got your notes down, and hopefully you're getting into heaps and heaps of practice.